Alright, so today we're going to talk about subtracting fractions. Yesterday we worked on adding fractions. Our main lesson was in finding a common denominator and renaming fractions. Today is about subtracting fractions, but the general work is still the same. Just view this day as a day to come closer to mastering the processes, because addition and subtraction are pretty much the same thing. So what we did yesterday was we took 5/3 and 3/8 and added them up. We first off started by counting by the bigger number. 6 does not go into 8. 8 times 2 is 16. 6 does not go into 16. 8 times 3 is 24. 6 does go into 24, and so 24 would be our common denominator. We then looked and said, 6 times what makes 24? Well, looking at your chart or doing what you need to lets me know that 4 works, so we multiply that to the top, which is 20. 8 times what makes 24 is 3. 3 times 3 is 9. And then in the end, you do 20 plus 9, which is 29, over, leave the bottom alone, 24. And what I explained is that you could turn this into a mixed number as you practice it by saying 24 goes into 29 one time with 5 left over, because 24 to 29 is 5 short, over 24. I said you do not need to worry about doing this, but it is good for you to actually practice. 7/9 plus 1/2. Again, counting by the big number. 2 doesn't go into 9. The next number for 9 would be 18. 2 does go into 18, so 18 would be my common denominator. 9 times 2 makes 18, so that turns into 14. 2 times 9 makes 18, so multiply the top by 9. 14 plus 9 makes 23 over 18. And once again, if that's an improper fraction, you can practice on converting this into a mixed number. 18 goes into 23 one time. From 18 to 23 is a distance of 5, 19, 20, 21, 22, 23. And then 5, and leave the bottom number alone, which is 5 over 18. Again, you do not need to do that, but that's just a skill you might want to make sure you practice so that you're getting better at the overall skill set of doing that stuff. The operations of addition and subtraction does not change from our operations on addition and subtraction in general. For example, we know that 10 minus 6 equals 4. So 10/13 minus 6/13 would be 4/13. We know that 2 minus 7 should be -5, because there's more negatives, and the negatives win by 5, or however you would think about it. So therefore, 2/3 minus 7/3 would be -5/3. We know that -1 plus -3 is -4, because there's 1 negative here, 3 more negatives there, 4 negatives altogether. Therefore, -1/11 plus -3/11 should be -4/11, because -1 plus -3 made -4. All the rules we've been working on do not change. The thing you want to do is make sure you do not lose the negative in the fractions. My best advice is to move the negative to the numerator when you're doing operations with fractions, so you don't overlook it. Again, that's coming from someone who's been doing math for almost 3 times your lifespan. So you are probably 14, 15 years old, and I have been doing math for over 40 years. So 44, 30-something years. Anyway, I've been doing it for a long time. So some examples of how I would rewrite the problem so you don't make a silly mistake. I would take something like this, -5/7 plus 2/3, and I would rewrite it moving the negative up to the 5. Because when you look only at the 5 here, you see a 5 and a 2, therefore you accidentally add them. Whereas here, you can see that it's definitely a -5 and a +2. If I had 3/4 plus -1/5, the 3/4 is fine, but again, that negative is in front, and sometimes you overlook it because you're looking across. Whereas here, if I move that negative up to the top, you can definitely see that that's a -1. So now notice how I did not rewrite the parentheses in the second problem, because the negative is moved to the top of the fraction. Therefore, it's no longer really needed to make it look more confusing than it is. So now that you've been informed about the level of expectation, let's discuss the process of learning. When you're given a worksheet, you have 2 requests. For every problem that you can get to. Number 1, make a true attempt. A true attempt means that you actually try to get it right. That means that you don't just write something down on paper to make it look like you're working. You actually try your best to get it right. If you are correct, that is great. But if not, you need to try to figure out what you did wrong and fix it for later. In other words, look for your own mistake, or ask someone, if you can't find your own mistake, for assistance. So if you know you missed a problem, for example, whenever I'm going over on the board, You need to either look to see what you did wrong, and if looking for it doesn't work, then raise your hand and say, hey, can you tell me what I did wrong so I can help you out? Or if they're in that collaboration time where you get to talk to your classmates, if they get a different answer and you don't see what you did wrong, ask them, and they might be able to look at it and see. And if that doesn't work, call me over and I'll try to, or call your teacher over and they can probably try to help you out to figure out what was going on. The trick with learning is that it's never really fun. But the moment you actually focus less on being perfect and more on getting better, things actually start to work out. So let's look at a couple of problems before we move on, and that should do it. 4/7 minus 2/3. So first off, I need to find a common denominator. 3 doesn't go into 7. 7 times 2 is 14. 3 doesn't go into 14. 7 times 3 is 21. I know this has to be my number because 7 times 3 makes 21. So 21 would be my denominator. From there, I know that 7 times 3 makes 21, so I multiply the top number by 3. From there, I know that 3 times 7 makes 21, so I multiply the bottom or the top number by 7. If you want to rewrite it, you can change that into a plus and move this up here. And now what I'm looking at is, I know I'm going to have 21 on the bottom, but in my mind, I'm looking at positive 12 and negative 14 being combined, and I know for a fact that the negatives win by 2. So it'll be negative 2 over 21. Or another way to write that is to move it back to the front as negative 2 over 21. Either one of these two things is right. They're fine. What you don't want to do is 2 over negative 21. Putting the negative on the bottom is not something we're actually allowed to do. But again, negative 2 over 21, which would be this one with the negative 2 on top, is fine. Negative 2 over 21 is fine, but either one of those two works just fine for what you're trying to do. Negative 3/4 plus 1/10. Again, what I'm going to do is rewrite this as negative 3/4 plus 1/10, because to me, that way I don't miss my negative 3. Looking for my common denominator, I'm going to count by tens. 4 doesn't go into 10. 4 does go into 20, which means that 20 is my common denominator. 4 times 5 makes 20. Negative 3 times 5 is negative 15. 10 times 2 makes 20. 1 times 2 is 2. And again, because I moved my negative up, I'm looking at negative 15 and positive 2, which makes negative 13 over 20. Or again, you could put the negative in front. Either one of those two is fine because they are the same exact fraction. All right. So after looking at yesterday and today, I think the point you should notice is that the words addition and subtraction really are confusing if you focus too much on whether you're supposed to add or subtract. It's really the same thing. Really, it's just addition. But our job is to use our understanding to determine whether the values work together, which means they add together, or eliminate, which means that they subtract. So just keep practicing. You'll get it down. Again, ask whenever you get stuck. But outside of that, good luck, and I'll talk to you later.